we're going to pick up right here. Yesterday we finished talking about reflections over the x-axis. Now we're going to do reflections over the y. And if you also remember, when we got towards those last couple, we kind of stopped describing all of the things. I'm going to continue to do that. I'm going to have us just graph them, talk about how it's moving, graph the movement. We're not going to be explaining all the things anymore. I think you guys are understanding that pretty well.
Or we have to explain on the quiz or test.
I don't know. I'll look and I'll let you know. Okay, so let's start down here. Reflections about the y-axis. These look a little different than reflecting over the x, okay? So a reflection over the y-axis, the negative sign is actually going to be inside of the parentheses or the square root sign or the grouping symbol, and it's only going to be applied to the x term. So when you reflect over the x-axis, the entire function was made negative. So everything had a sign change. When it's the y-axis, only the x term is the one that's going to switch. If there's numbers or there's other terms that follow it, they're not going to be affected by the negative sign. So you can hopefully see down below on all those examples that the negative sign is now placed on the interior, like inside the parentheses, inside the square root sign, inside the absolute value brackets. So this is just your signal to know this is going to reflect it over the y-axis for all of these. Now we do have some other movement happening. What is going on for the first one? What is that +3 going to do? Ooh, careful. No.
Down 3.
No.
Up 3.
There you go.
Yeah.
Up 3. If it was left or right, it has to be in the parentheses. It's outside of it, so that's why it's going to go either up or down. What's the -2 going to do?
Yeah.
Good. Down 2. And the +1? Good. Up 1. All right. Let's graph these. So let's start with this first one. This is just a parabola, so a U shape. So remember from our parent, we've got points at 0, 0, on either side at 1 and -1, and 2, 4, -2, 4. Okay, and then we're going to go up 3. So all you have to do is shift it up, and then we'll also do the reflection here as well. So I'm going to go up 3 first. It's kind of like what I was doing yesterday, but then we're going to be reflecting it over the y-axis. But I have a question for you. If I go up 3, I'd be right there. How is that point going to get reflected if it's on the y-axis already?
-3. It's not. Oh, dang.
It's not going to move. That one's going to stay there. So now think about this 1, 1. If I move that up 3 and I'm here and I reflect it over the y-axis, where's it going to go? To the other side, right? Still at 4, but over here at -1. If I were to do the other side, so I'm not going up to 2, 4. I'm going over to -1, 1. If I go up 3, I'm on that dot that I already made, but that would get reflected over to the other side. So that would be coming over here. Is this graph really going to look all that different?
No.
No, because when you reflect a parabola about the y-axis, it's already symmetric there. So when you flip it, it's almost going to look the exact same. Those points are technically moving. We just can't really see it on the graph because of the nature of where we're at. So then same thing with 2, 4. Yes, you're moving it up 3. You are technically reflecting it, but it's right now going to look the same because you're reflecting over the y-axis, which is that line of symmetry. So this right here tells you that you went over the y-axis, but like I was explaining to you, that y-axis is in the middle of the graph, so it doesn't really look like a reflection happened. Okay, so let's go on to the next one here. This is that cube root function. I'm going to start by graphing the original. So we're at 0, 0. We're going to go up 1. So like 1, 1. And then we also had 8, 2. -1, 1. And then -8, -2. Okay, what movements are happening here? Down 2, and it's being reflected over the y-axis. Some of you might actually maybe even just want to do these separate. like maybe you want to do the down 2 movement, graph that one, and then do your reflection. So you'd have like 3 graphs total. I'm okay if you want to do that, especially if that helps you keep track of your points. Because it can get a little bit confusing when we have a lot of movements happening. Or you could move your points down and then do what I do, like draw like an X there first and then think about what happens if I reflect it. Well, again, that point's on the y-axis, so it's not going to move. So I'm going to go ahead and just keep that point there. Okay, then if I go to my 1, 1 point, I go down 1, 2. If I reflect it over the y-axis, where does it go?
Which one?
I put an X on the spot where I moved it down to.
It goes to
the negative 1, negative 1.
Yep, so right there. Okay, now I'm going to my point that I have at 8, 2. If I move that down 2, then where does it go?
Which one are you talking about?
I went to 8, 2, so the point way over there on the right.
Yeah.
I moved it down 2, that's where my X is.
It goes to -8.
Now it goes to -8, good. Okay, let me get those X's out of there. Now we're going to do the same thing with the negative side. So I only focus like on the top half right there. Now I'm going to go to the bottom half. So I'm down here at this point, -1, -1. I'm going to move it down 2, which would be here. And then I have to reflect it over the y. So it'd be there. Then I do the same thing at my -8, -2. I go down 2, I'm here. I have to now reflect it over the y-axis, so it flops over to this side. And then we graph that. I just want to show you, if you graphed them separately, if you just did the down 2 movement first, you don't have to do this. But that green line would be just the down movement. The blue one is when you do the reflection. Again, if that is helpful to do them separately like that, feel free to graph all of them. It can, like I said, be confusing when it's like, okay, this has got to go up and down or left and right, and I got to do a reflection. Like there's a lot of things that can start to happen there. Okay, last one in this area here. We've got an absolute value graph. So remember, that's just that V shape. What direction is this going? Up 1. And then if I reflect it over the y-axis, is it going to look any different? This is just like the parabola. It's already on the y-axis. So yes, there's a reflection happening. It's just not going to look like it. So for most parabolas and absolute value, if you're only moving it up and down and you're doing a reflection over the y, there's really not going to be a lot of change. Now, it would start to get a little bit different if I was moving it left or right, because then it would change its distance from the y-axis, and then there would be more of like an obvious reflection that was happening. All right, do you have any questions on the difference between x and y-axis reflections? Okay, so go ahead and turn your page over. The last types of transformations we need to discuss is when we can like stretch a graph, or we'll call it shrinking, or someone might also say the word compressing, like we're compressing the graph down. Stretching means you take your graph basically and you're trying to like pull it up really, really fast. And so it stretches that thing. So it doesn't start to look, what's the word I'm looking for? It's not a dilation, because not everything is moving in the same direction. It's a stretch because it's being pulled in one direction. So a stretch could be vertical, it could be pulled up this way, or it could be horizontal. Stretch could be stretching it out this way too. You could also have it being compressed, which means you're trying to like smush it down. So you could compress it vertically, or you could compress it horizontally too. So to understand the difference between them, there's going to be numbers that are thrown in like the front of your function. And up here in like this definition area, it kind of talks about this. If there's they're going to call it the c value. If the c that's placed in front of your function is greater than 1, if c is greater than 1, and it's placed in front of that function there, this is going to be a vertically stretched. Like it's going to stretch that thing vertically, which would mean it's going to pull it up and down. And you're going to multiply all the y coordinates by whatever c is. If the number is in between 0 and 1, so this most of the time is going to look like a fraction, like a half, a fourth, something like that. It's still going to be that number sitting in front. This is going to vertically shrink, or we could call it compress. It's going to make that graph go down more. It's going to take it longer to grow, is basically what's happening when we compress something. You're still going to multiply the y coordinates by your c. So let me show you what I mean. Down below we have two examples. This first one, well, they're both just parabolas. So let's just go ahead and on both graphs here, graph the original graph. Okay, so I've got my parents graphed on both because they're just plain parabolas. Now this first one has a 2 sitting in front. That 2 is going to stretch your graph. So I'm just going to write stretch above it. That means that I'm going to take all my y values and I'm going to multiply them by 2. So that might be something that you would even want to write as well. You're going to take 2 times your y values. Your x values are not going to change. So like you're still only going to go over 1 or you're only going to go over 2. But now instead of your y values being at 1 and positive 4, those are going to have to get doubled. 0, 0 is going to stay where it is because 0 times anything is still 0. But if you think about this with me, I'm at 1, 1. So I'm at this point right here. The y is a 1. What's 1 times 2 though? 2. So instead of going up 1, you actually need to go up 2 to represent that stretch. And then the same thing's going to happen on the left side. Because it's still a parabola, it should still be reflexive on both sides of that line. My other point up here, which is at 2, 4 right now, 4 is my y value. What would be 4 times 2? 8. So I'd be up at 2, 8. Then if you start to graph that, you should hopefully recognize that your parabola is a little bit skinnier now, and it's getting taller faster. That's what a stretch is going to do. It's going to pull that graph up. It's going to make it speed up the process of its movement, basically. Now, what's going to happen on the second one? It's going to shrink it because of that 1/2. So this is going to make it shrink, or like I've been saying, someone might say compress. This is going to kind of force it to slow down. It's not going to allow it to grow as fast. What are we going to take times our y values this time? 1/2. Because that's that number in front. So I'm going to take 1/2 times all of my y values. Again, my x's are not going to be affected at all, just the y's. So again, my y value was at 1. What would be half of 1? Half. So you're going to go over 1 and only go up 1/2. I'm going to zoom in on that because it does get a little bit smaller. My next y value was at a 4. What's half of 4? 2. So you're going to go over 2, up 2. Then you can connect that. And hopefully for this one, you can recognize that parabola is taking longer to grow upward. It's more wide because of that compression. It's kind of being forced down on the graph, and it's going to move slower. So it's still going to open up as a U shape, but it's going to be a little bit wider, and it's going to take longer for those numbers to get up higher because of that 1/2. Again, if they wanted you to describe all the things about the graph, we could, but we're not going to do that right now. Okay, so when the number is in front of your function like that, that's a vertical stretch or compress. But now let's talk about horizontal. Horizontal stretching and shrinking, the rules are the same as far as like how the numbers impact what's happening. Like if it's a whole number, it's going to stretch it. If it's less than 1, greater than 0, so fractions again, it's going to be compressed. But this time, it's going to be inside the grouping symbols. So in the parentheses, in the square root sign. Again, we're kind of just switching where it's sitting at in our function. What you need to do here is instead of multiplying, you're going to divide the x coordinates by your c. So on the vertical one, think vertical as your y-axis. It affected the y coordinates. Horizontal would be your x-axis. So this is going to affect your x coordinates. We're not multiplying though, we're dividing because this is going to impact what's going on this direction. Again, we've got 2 parabolas down here, so I'm just going to start by graphing both of those parents. Okay, and so now when we graph these, we're thinking about our x values. And this first one, you're going to multiply by 2. So you're going to take 2 times our x values. Not the y's this time. So your vertex still will not move. It's going to still be at 0, 0. Okay, my first y value, though, was a 1 because I went over 1. So I would multiply that by 2. So I would actually go over 2, and then still you would go up 1 because your y is not going to change. Then I would go over -2 and up 1 to reflect that on the other side. Okay, my next point that I have was 2, 4. 2 is my x value, so what's 2 times 2? 4, so you're going to go over 4, up 4. And there's your parabola. So it looks a little different than what we saw up above, because when we were doing it horizontally, those points were, it was opening up wider, like this one is, but those points were taking a longer time to scale the y-axis. These ones, the y numbers are still the same, but it is opening that graph up a little bit more because of our x being affected. What's it going to look like for the second one? What's this 1/2 going to do? It's going to compress it. We're still thinking about like you're taking all the x coordinates divided by a half. Okay, so you have to kind of think about that a little bit backwards almost. So you're going to take half of all of your x coordinates, which is going to look like this. You're going to have a point at half 1 and then 1, 4. And then -half 1 and -1, 4. It's almost opposite of what we saw happen up above. If I just zoom out big picture here. Up above, when you had a whole number, the graph got really skinny on a vertical stretch. On this one, though, the horizontal compression actually looks like a stretch a little bit. So being able to keep those straight is kind of tricky sometimes. This would be great information to like be putting on your note card, like your parent graphs and like writing down all these little things that I've been highlighting, like this number does this, and you multiply this coordinate or you divide this coordinate. All right, to wrap it up, we are going to do some problems where we have to combine everything that we've been talking about. So it's going to be doing all kinds of transformations. It's going to be moving it left, right, up, down. Maybe there's a reflection. Maybe there's a compression. We have to figure out all the things, and then how do we graph it? So the first thing I want us to do is just figure out what's the parent graph. So what is the original function for this first one? Yes, the S-looking one. Because of that to the third power, your parent graph, and I'm just going to write this above, would be x to the third. Okay, and that's where I'm going to start. I'm going to graph the parent first. So that's at 0, 0, 1, 1, 2, 8, -1, 1, -2, 8. Okay. What's going on up here? What is this -1 doing? Okay, so this is going to move it down. What's this plus 2 going to make it do? Good. Nope, you were correct the first time. It's going to make it move to the left. That one's backwards for our brains. Okay? I'm actually going to start here first. I'm just going to move it these directions because I'm afraid if we do too much at one time, you're going to get lost. So I'm going to go all of these points that I had graphed. I'm going to move them all left 2 and down 1. Okay, now let's talk about the -3. There's two things happening here. The negative means something and the 3 means something. The 3 is on the outside of your function. So this is going to be a vertical stretch. So I'm just going to write this out. Vertical stretch of 3. And then what is that negative? Since it's out front, what kind of reflection is happening? Good, x-axis. So I'm just going to write that above this here, x-axis. Now you could do these separated as well. If you don't want to do them both at the same time, you could do the stretch and then you could do your reflection. So I'm basing this all off of the green one now because I moved it from the parent. So now if I do a vertical stretch, remember that the rule there is that you multiply your y coordinates. I'm just going to write that after this. I'm going to say multiply y coordinates by 3. So let's start at this first point. I'm going to kind of get up so I can point to it. Talking about this one here. This is at -2, -1. -1 is your y. So if you take that times 3, where does it go? -3. So you're still going to go over -2, but now your new vertex is going to be down at -3.
So can you just reflect it right over?
Then you can reflect it right over that if you'd like. So you can go down here. That's where the stretch would be, but then you have to reflect it. We're reflecting it over the x-axis we said, so it's going to force it to go up here. And that's where the final point would be. Again, if you want to do these separated, like you want to do the multiplying by 3 first and then do the reflection, you could do that as well. But at that point, I took that y value of -1 times 3. That's why I'm down here at -3. And then I would reflect that back up. So my final point would actually be right here. Okay, then let's think about those 2 points that were on either side of I call that like your vertex because that's where the graph changes its movement. So if I look at this point here, what's the y value of this point?
0.
0. So 0 times anything is
0.
0. Okay, so this point is going to stay here, but it's got to be reflected. So is it going to move?
No.
It's going to stay right there. So we're going to have a little bit of overlap. And then I'm just going to go to this point right underneath the vertex. What's my y coordinate here?
Where 2?
-2. -2 times 3 will be -6. And then you got to reflect it. So you're actually going to go up. Hold on. I did something wrong. I think I have my vertex in the wrong spot. Well, hold on. Maybe I don't. Because it should go down this way, and it should go up this way. There's other points. We just didn't do them. What did you say? It did, though. It crossed the y-axis here. It would eventually cross the y.
Yeah, that's what I was thinking.
Yep, it would. I just, I didn't do this tall point here, and I didn't do this point here, because if I have to start multiplying those y's by 3, it's going to go way off my graph.
Yeah.
So I just kind of stuck to those 3 main points, like the vertex and then like a point on either side. All right, let's do this last one. What's our parent for this last one? Good. It's the V looking graph, so it's just absolute value. Okay. Let's first just talk about, is it going to move left, right, up, or down? Good. Up 2, right 3. So I'm just going to write that down. Right 3, up 2. And I'm going to do that first. Okay, so my green one now is reflecting that. And then what else is happening? What is this 4 going to do? I still think it's vertical because it's not in the brackets. If it was inside of the grouping symbols, then it would be horizontal. So this is a vertical stretch. So what do we need to multiply by 4? The y coordinates. Okay, so you're going to multiply your y coordinates by that. All right, so if we do this, when we're combining this, you're thinking about, it's still going to start here at 0, 0, or not 0, 0 anymore, but like where that got moved over, because I didn't quite reflect, or my graph doesn't reflect that there was this stretch happening. So now if I look at that point 1, 1, I would take that times 4. So it's going to increase up by 4 points. So I'm going to draw this graph here, and it's going to go up to, I have it up here. And that's going to be on either side of my vertex there. That's showing the stretch. And I don't need to do all the points. You just need to do at least one to kind of show me what happened there. So your x coordinate is unaffected. Okay, but this x, or the y coordinate here was at 2. Oh, so maybe I went up 2. No, I didn't go up far enough. I should go up to 8. Because I'm at 2 here, I gotta multiply this by 4, so actually those dots should be up at 8. So let me fix that. There you go. And then you could do more points, but they're gonna go way off your graph. So for most of these, when they start to throw in those numbers, I would just focus on the vertex and maybe a point on either side of the vertex to get your overall shape of the graph. Do you have a question? No? Okay. All right, that finishes up that section.